Alright, welcome to part 3 of chapter 3 of stoichiometry. And the last bit is a very short video on limiting reactants. I broke this separately because I think that it's one of the hardest concepts that students have in thinking about the calculations along with it. And so trying to just get you to focus in on just this one little thing. So the easiest way to think about it is if you think of a grilled cheese sandwich, right? For every grilled cheese sandwich you're going to make, you need 2 pieces of bread, and you're going to put the cheese in the middle and toast it, right? So if you were told that you had 10 pieces of bread and 7 pieces of cheese, how many sandwiches could you make? Right, you can only make five sandwiches, and that means that you would use up all the bread, right? But you would have 2 slices of cheese left over. So it tells us that bread is the limiting factor, right? Because we only had 10 pieces. Whereas cheese was the excess reactant. There's cheese left over. Well, in chemistry, we talk about the number that we need in number of moles. Okay? So if we look at this figure, this is our before the reaction is started. We have 10 moles of hydrogen gas and 7 moles of oxygen gas. Okay? And if we look at the balanced chemical equation shown here, we know that it takes 2 moles of hydrogen gas and 1 mole of oxygen to produce 2 moles of water. So this is hydrogen gas is our bread. We need 2 pieces of hydrogen gas. Oxygen is going to be our slice of cheese, and we only need 1 mole of oxygen gas. So if we look at what we're starting with 10 pieces of hydrogen gas, right? So 10 molecules of hydrogen gas, 10 moles, and 7 moles of oxygen gas. So we need 2 of these for every 1 of these. And so if we look at after the reaction is complete, what you have is you end up forming 10 moles or molecules of water, and you have 2 moles or molecules of oxygen gas left over. Okay, and so that's just shown here in this equation where we have 10 moles of hydrogen gas that we're starting with. We use all 10 moles. We have 0 left. With the oxygen, we started with 7. We use 5. We have 2 left. And the water molecules, we end up with 10 moles total. Okay, so we can identify the limiting reactant as the hydrogen gas because we have 0 left over. Excess reagent is the oxygen gas. So the next slide is going to take us through some steps that you can use to solve these limiting reactant problems. And I would definitely suggest that you watch the practice problem videos to fully understand these calculations. They are complex. So for an example problem, we would ask something like when a 2 gram strip of zinc metal is placed in an aqueous solution that contains 2.5 grams of silver nitrate, we can show this reaction as zinc plus silver nitrate, right? So we're starting with our strip of zinc metal, 2 grams of this, 2.5 grams of the silver nitrate, right? We're going to end up producing silver and zinc nitrate. So the question would be, which of the following is the limiting reactant? Well, if we start off going through the series of steps that I've identified here, we can solve this problem. So step 1 is make sure the equation is balanced. Okay, we can check that, and it is. Secondly, convert the reactant's mass in grams to moles. Right? We can't compare grams to grams. We have to compare moles to moles. And so we're starting with 2 grams of zinc and 2.5 grams of silver nitrate. So we can convert both of these to the moles of either zinc or silver nitrate. Step 3 says divide the moles of each reagent by its coefficient. So however many moles of zinc we have, we can divide by 1 because there's a 1 here, right? And for silver nitrate, when we convert these grams to moles, we can divide by 2. So what that gives us is if we take the value that we get in step 3, okay, to the amounts identified in step 2, then we can ask ourselves, am I starting with enough product, right, which is what we calculated in step 2. So we can ask ourselves, am I starting with enough product by comparing to the theoretical value calculated in step 3. So step 3 is our theoretical value, what we should actually need in order for this reaction to proceed, okay, and use up all the reagents. Step 2 is what we actually have and what we're starting with. So this will allow you to determine which reagent is limiting. Thus, you can identify the limiting reactant, okay. So these, I would definitely say practice, and that will help you out a lot. Step 5 is just to determine how much product is basically formed. So we ask, how many grams of zinc nitrate? So our product, how much of that is formed? Well, we can just multiply the limiting reagent by the coefficient of the product. Okay, and this is just like solving a mole-to-mole conversion that we talked about in part 2 of chapter 3. So if you're confused about that, go back and think about if we start with so many moles of one product, how do we compare it to moles of another, or one reactant to a product? And step 6 kind of goes along with this question 4. So how many grams of the excess reactant are left at the end of the reaction? So it's really used to determine how much of the excess reactant is left over after the reaction is complete. And so here we're converting the moles of the product back into grams for the concentration. Okay? And there are some examples of these, so I really encourage you to go through those and let me know if you have any problems. The last thing we can discuss is the theoretical yield. So in the lab, we need to determine the amount of product that can be theoretically produced by the chemical reaction. And this is what we call the theoretical yield. However, as scientists and humans, things don't always go as planned. And so we rarely ever get the amount that we theoretically should, right? But what we get is our actual yield. And so to calculate the percent yield, we can just take the actual yield and divide by the theoretical yield, multiply by 100, and we have calculated our percent yield. And you will do this numerous times in the lab if you are enrolled in that. So make sure you calculate this and you can do this as well. And that concludes chapter 3.